Thank you for taking the time to attend our presentation, Understanding HL7 version 2.5.1 and Meaningful Use Data Considerations. Our speaker today is Rich Murphy. Rich is Vice President of Interface Software at HL7. Rich has a Bachelor of Science degree in Engineering, a Master of Science degree in Computer Science, and more than 15 years as a healthcare IT professional and integration strategy expert, in addition to being an experienced programmer. He joined HL7 in 2003 to oversee interface development, implementation, support, and day-to-day operations. And now I'll turn it over to Rich to get us started.
Thank you, Amanda. Wanted to just take a quick moment and thank everyone in the audience for attending today. Appreciate your time here today. Today I wanted to take a look and discuss a brief overview of HL7 version 2.5.1 and get into some of the details there with version 2.5.1. We'll talk about the specific codification standards, and I can explain those a bit here in a few slides, that are required in version 2.5.1, and we'll look at some examples of each of those. I wanted to briefly discuss clinical documents and what we're seeing with those, as there is some overlap with version 2.5.1 and clinical documents. And I also wanted to briefly take a look at the new or newer HL7 framework called FHIR, for anyone who hasn't been exposed to that, just to get some exposure to that, as we are seeing FHIR as part of Meaningful Use Stage 3, at least currently as it's written. Just very briefly, just quick history, HL7.org. So as I'm sure many of you are aware, HL7.org is an accredited standards development organization, SDO, focusing primarily on clinical and administrative data. HL7 develops standards to improve information sharing and provide interoperability to allow information exchange between disparate systems. And the URL, as I'm sure many folks are aware, would be HL7.org if you want to check out anything on HL7 on their website. Taking a quick look at HL7 version 2 and its history, because that leads into version 2.5.1. The base version of HL7 version 2, so as HL7 comes out with a new version of each standard, they assign it a number, and the family that we're looking at today, the base version is version 2. So version 2.1, 2.2, 2.3, etc. So we're in the version 2 family today. So the base version 2 itself was created in 1987, and it has evolved quite a bit since that time. Although we're talking about version 2.5.1 today, the current version of HL7 in the 2 family is version 2.7. So there are some versions after 2.5.1, but today, again, we'll be focusing mainly on version 2.5.1. And just some quick interesting stats from HL7.org. 95% of U.S. healthcare organizations use HL7 version 2 in some capacity, pretty respectable number there. More than 35 countries have an HL7 version 2 solution in place as well. So HL7 is an international organization, and everything we're seeing with version 2.5.1 does have international integration in mind. It is worth mentioning briefly that HL7 version 3 does also exist. That was approved in 2003. So HL7 version 3 is a complete departure from version 2. So even though you have the HL7 version 2 family, and within that family, we're talking about version 2.5.1 today, and we'll talk about version 2.3 a little bit as well. We're still in the version 2 family, if you will. They're similar standard. When you get to version 3, it is a complete departure from version 2. So I like to mention that because version 3 isn't just, the next version of 2. It was designed sort of from the ground up, taking all the lessons learned with version 2 and kind of getting the best of, any lessons learned with new technologies and new approaches and things like that. But version 3 is a complete departure from version 2. That being said, even with version 3, you would think that as new versions come out, that just supersedes the previous version, and the previous versions become obsolete. Not necessarily the case with the version 2 family. I mean, HL7.org does envision that the version 2 family is going to continue to play a critical role in healthcare interoperability for many years to come. So everything we're going to talk about today with version 2.5.1 should still be relevant with healthcare interoperability for many years to come, even with version 3 out there. So with that in mind, now let's wanted to start taking a look at some of the details. Version 3 is out there, and there's different versions of 2. Why would we use version 2.5.1? What are the reasons for using specifically version 2.5.1? Well, for starters, meaningful use stage 1. So what we found, and I'm sure many on the call found this as well, that version 2.5.1 was required. It was a required component for meaningful use stage 1 back in 2011, 2012 for the reportable labs, the clinical documents, which use a portion of codified values for that, and that was the main requirement for stage 1, was the reportable labs and clinical documents as far as 2.5.1 goes. Now, it got a little tighter when we got into stage 2. So as we get into stage 2, version 2.5.1 is also required for the same things that it was required for stage 1, reportable labs and the clinical documents, but the public health interfaces. In stage 1, the syndromic surveillance interface was allowed to use version 2.3, or version 2.3 was permissible, I should say, for syndromic surveillance in stage 1, but not so in stage 2. 2.5.1 is required. Same with the immunizations, part of public health interfaces. Version 3 was allowed at stage 1, but not so at stage 2. We also see versions 2.5.1 coming into play with stage 2 for transmitting lab tests and results, either as part of public health, the public health interfaces to send reportable labs to your state, or as part of sending electronic lab results for ambulatory setting. We saw both of those, and those both use 2.5.1 in stage 2. And I mentioned the clinical documents as well, so that carried over from stage 1. In addition, for stage 3, while we are still in the comment phase for stage 3 and the requirements aren't set in stone, anyone that's taken a detailed look at the stage 3 requirements, you'll see that version 2.5.1 is also, part of the stage 3 write-up. It is specifically mentioned for some of the specific objectives. Again, it's currently still tentative, but no reason to think that the 2.5.1 portion is going to change for stage 3. Specifically, if you look at the public health interfaces, those contain the same public health interfaces that we saw in stage 1 and 2, the 3 outbound syndromic surveillance, immunization, and reportable labs for the state. But we're also seeing stage 3, the public health interfaces are now being expanded to include additional information, cancer registries and some other things, but also bidirectional for immunizations. If you look at the language for stage 3, the immunizations call for actually sort of a query and return sort of model with immunizations, and that does use 2.5.1. Again, the clinical documents as well, same with stage 1 and same with stage 2. Lab orders, so for CPOE, providers being able to place orders to meet that objective. That objective wasn't, was part of stage 2, but specifically for stage 3, that calls for 2.5.1. To support that and the lab results, there's also the concept of the electronic directory of services, or what we might call a lab test compendium. So the list of all of the orderable lab tests that somebody would be concerned with, that has overlap with CPOE and the lab results interfaces for stage 3, all using 2.5.1. As far as vendors are concerned, so on the vendor side, vendors really, we need to be able to use 2.5.1 for a few different reasons. So above and beyond meaningful use, some things that we do see that as part of grant requirements, for example. I know that some states have been requiring 2.5.1 for some lab result grants. I think Ohio had one a few years ago, even before meaningful use. So some states have been requiring 2.5.1 just as part of grants, even before meaningful use many years ago. We are also seeing growing acceptance in HIEs, so pushing data out to an HIE, bringing data back in from an HIE, both using version 2.5.1. As vendors, one thing that vendors have to worry about is we have to, for meaningful use, meet all the requirements. If we want to offer, if a vendor wants to offer a solution to be used to meet a specific meaningful use objective, no matter which objective it is, menu, optional, stage 1, stage 2, vendors have to get their offerings certified. So each solution needs to be certified if you want to be able to offer it, to a hospital to be able to use for a specific objective. Well, to pass that certification, the certification for many items just requires 2.5.1. So right out of the gate, before we can even complete our code and sit for certification, we have to conform and make sure it's version 2.5.1. And also, vendors need to conform to the receiving system's specifications. Typically, when an interface vendor is creating an interface to push data out to some receiving system, typically the receiving system will have some preference about how they want the data sent, and we're seeing that many vendors just require 2.5.1 with all of the messages. That's just what the vendors want. So as an interface vendor, we need to conform and be able to match 2.5.1 if any receiving system wants 2.5.1, whether it's meaningful use or a grant, HIE, or other. And again, so for us as a vendor, we need to certify each solution, and if we even want to operate in the meaningful use space at all, the things that the ONC says have to be 2.5.1, we just have to conform to that to be able to certify and offer solutions. So let's take a deep look. That's a little bit of the history of, I like to know with version 2.5.1 before we look at the details, a little bit of why, I like to know the why behind it. Why does a hospital care? I presented this at Muse, and that was the way I looked at, why does a hospital care? Why should a hospital care what version of HL7 we're using? As long as it works, why would a vendor care? The vendors figure that out. Well, there are different reasons why the hospital and the vendor both, need to care why the HL7 version 2.5.1 is being used. So taking a deeper look at version 2.5.1, let's look at a little bit about how the standard is set up. So as I mentioned, version 2.5.1, it is built upon previous versions in the version 2 family, and it takes advantage of some of the same concepts that we see with version 2.3, for example. So anyone that's familiar with version 2.3, some of these concepts are identical. The concept of messages, so to actually exchange data between two systems, version 2.5.1 does use messages for that. If you dissect each message, you'll find that in version 2.5.1, those messages are made up of segments and fields, just like you're used to in 2.3. The 2.5.1 messages will contain segments and fields. Those messages will contain a message type that's used to define the intent of each message. Is this an ADT message? Is this a lab result for the state type of message? Things like that. Is this a syndromic? Is this a vaccination, immunization? What type of message are we dealing with? You'll find that control characters, the same delimiters and the same data types that were present in version 2.3 also apply to version 2.5.1. And as messages are pushed out, as that system receives those messages, the concept of acknowledgements still applies. So each receiving system sends out an acknowledgement when they receive a message, just like you're used to in version 2.3. So if you're comfortable with 2.3, those portions stay the same in version 2.5.1. The largest, or one of the largest differences you'll find when you compare version 2.5.1 to some of the other HL7 versions is the codification. So when we look at codification, what we mean is to be a valid HL7 2.5.1 message, the interface, which is creating that message, must populate certain fields with specific codified values. You just can't just put whatever you want in there for, the lab result or the test identifier. So we'll take a deeper look at each of these here in a couple slides. But that's the key difference with version 2.5.1 and prior versions is the codification. And this is where you'll see some of the challenges as a hospital, some of the time that goes into building these and testing them, and some of the challenges you might see on the vendor side with vendors being able to actually manipulate and change an interface or not manipulate and change an interface depending on what the need was and the request was. But some of the specific codification considerations that you'll see, link codes, the SNOMED codes, UCOM, the CVX and MVX for the immunizations, and then of course ICD-9 and 10, procedure and diagnosis codes. So taking a quick look here at each of these. So link codes, you're going to see this with the lab system mainly. We use this to identify the lab tests within the messages. So as you look at each lab result, the tests that are in that lab result, you're going to see the link codes used there to specify downstream, what these lab items are. One nice thing about link codes is that the spec allows, 251 allows the local coding system, so in this case Meditech, the local coding system's identifier or identifiers for each lab test can be sent along with the link code to assist with data mapping. So that means in the case of lab, you can send the lab print number, or the test number, the test identifier, in addition to the link code, which just helps with troubleshooting. As you look at the actual HL7 message, being able to see the Meditech value and the link code just helps you, more efficiently and quickly understand what Meditech value was sent for troubleshooting. But the version 251 does allow that and does support that. SNOMED codes, so the Systemized Nomenclature of Medicine. This is the global clinical content terminology, and where you tend to see that, or we tend to see that, is with the lab and the micro results. Specifically, there's a few specific examples: the organisms, specimen type, the procedures, and it can also be part of the patient's problem list. There's an example of a symptom there. So different SNOMED codes and how you might see those used specifically with lab and micro results. Units of measure, so the UCOM codes. So these are designed to really cover all units of measure, kind of a fun one, all units of measure being used in international science, engineering, and business. So, not much to deal with there, right? International science, engineering, and business. Yeah, sure, no problem. So UCOM codes are meant to cover all of that, again, internationally. And kind of the interesting thing about UCOM codes is electronic. They're designed to emphasis on electronic exchange of these units. So used to report units of measure throughout various interfaces. Just some examples of what you'll see as you look at meaningful use in 251 in terms of UCOM, some examples of milliliter, Fahrenheit, micrograms per milliliter, again, typically with the lab type results, micro, things like that. But of course, degrees Fahrenheit could be in lots of different places. But you will see the unified code it's a measure throughout. As far as immunizations, so we see the vaccine administered and the manufacturers of vaccine codes, so the CVX and the MVX codes, and that's put out by the Centers for Disease Control, the CDC. So again, they just have tables that for the vaccine administered and the manufacturers, we need to provide the right CDC, CVX and MVX code for the interface that we're creating to be 251 compliant. And the system which receives that message needs to be able to understand these codes, CVX, MVX codes, all of them. As far as ICD-9 and 10 goes, where you'll see that, where we see that the most with 251 would be the patient's problem list. Again, those public health interfaces, the immunization, syndromic surveillance, and lab reportables for the state, and also with clinical documents, you'll see those ICD-9 and 10 codes. Just a quick sample message. This is just sort of a random OBX segment here in a, looks like a micro result. So just to show you some of the, unified measurement codes there, just different places where you'll see them in the message. So what do these codified values mean? There's definitely some impact for the hospital, for vendors, for outside systems, for everybody. So as far as vendors go, Version 251, once an interface is set up and it conforms to version 251 and all of these codified values are proper and are being sent, well, for starters, for meaningful use, like I say, the right data must be sent. So the interface has to send the right data in the right format, just to be certified, period. You can't be certified unless you send the right data. Once you're in that format, once you've gone through and confirmed that the interface matches 251 specs and meaningful use specs, what that means is really each interface vendor must review change requests that come in. And as an interface vendor, what you need to do is make sure that as long as anybody is free to ask for changes to an interface, as changes are requested, the interface vendors need to make sure that changes aren't being done to the software which would negatively impact the certification and negatively impact the 251 standing. So to help, there are data validation tools available to help software vendors such as ourselves, make sure that all of our interfaces conform before we even sit for the certification test. But once we have, a main one here is with NIST, the NIST validator. Once we've confirmed that an interface matches, we really need to scrutinize and evaluate every single change request to make sure we're not, I say breaking and offering, but what that means is there are some fields that can be changed and an interface is still considered 251 and, nothing's broken. There are some fields which cannot be changed. So for example, the link codes, we couldn't change an interface and just remove the link codes because somebody didn't want to receive them. 251 requires the link codes. We're obligated to send those link codes. If a receiving system can't do something with the link codes, that's an issue, but you wouldn't want to remove those from a clean, and proper 251 interface and then cause that interface to no longer be considered 251, for example. So what that means for the hospital is as you're requesting changes with vendors, IATRIC and others, you don't be surprised if you see, if it's meaningful use, if it's 251, vendors spending more energy and time, and they might have more qualifying questions to just part of the due diligence, making sure that every change being requested and every change being made isn't going to cause an issue as far as certification in 251 goes. So for example, in that case, if somebody asked to remove the link codes, the right answer would be, we can't remove the link codes without making this, potentially not match 251 anymore. And we want to make sure this is 251, so we really need to leave those link codes in there. So it just means that all change requests must be reviewed to ensure continued 251 compliance. So on the hospital side, that's probably the main reason you would see where it might take a vendor a little bit longer just to review a change request and get back an answer. Before that, with version 2.3, it's not uncommon for hospitals to reach out to vendors and vendors to say, to make a quick change, maybe the same day. Hey, can you move a field? Can you add a field? Can you take a field out? Can you change a field? The data in 2.3 wasn't as strict, wasn't as codified, so vendors have a lot more wiggle room in terms of changes that could be made. But just a consideration with things that need to be looked out for with 251. Mapping. So with vendors, one tool that most vendors use and most hospitals have probably seen by now is mapping. So mapping is a common tool. Mapping can be used to take non-codified values from the hospital backend system and marry them up and match them to their codified counterpart, which the version 251 spec requires and calls for. Mapping is typically done, it may be needed. It's not guaranteed for every single field, every single interface, but it may be needed to match up, and I'll show you an example of this here in a moment. Typical fields that we see, typical interfaces where mapping comes in quite a bit would be the home medications, so things like the drug, the route, the frequency, the dose, the delivery method, things like that. The values need to match up between the HIS system and what 251 requires, so you'll probably see mapping there to get the 251 equivalent for each field. Allergies, the value, the severity, the type, same idea. Problems, link, again, the codes that need to be in these interfaces, link, SNOMED, UCOM, etc. Mapping can be used to both produce those codes and to start with those codes and produce the value that the HIS system wants. So I can show you some examples of that. So quickly looking at an outbound example, the way that would work would be sort of a step-by-step process. So with an interface, typically that'll collect the data electronically from the hospital system using that hospital's dictionaries. So in the case of Meditech, the data is going to come from the Meditech lab dictionary, from the nursing system, from pharmacy, from the drug dictionary, from the RxM home dictionary, things like that. Mapping is typically then applied as step 2 on those fields with the hospital's input to produce the codified value. And now the output is compliant with what 251 requires. The receiving system may or may not be aware that the mapping even took place. So that's an important part. Important point is that if a map is used to take, for example, a Meditech drug mnemonic, pharmacy drug mnemonic, and produce a value that is a codified drug so that it's 251 compliant, the system who receives that might not even know the mapping took place. They just receive, they're probably not even going to get the Meditech value. They can if it's desired, but they might just get the codified value. So they might not even know that the mapping took place. I mention that just because for troubleshooting, sometimes you might deal with vendors, and if you talk about mapping, the vendor downstream might say, what are you talking about with the mapping? I mean, this is the code we got raw in the message. It's not being mapped on our side. So you might need to actually go upstream to the system where that mapping is taking place. So just a quick visual of how that works. So kind of going left to right, this would be an example of an HL7 251 output being created, starting with the Meditech data. So this is your Meditech data in the database and your dictionaries is where it starts. In Meditech, next, people can reference the IMO mapping tables. We reference those. Other people can reference those as well. So we can take the Meditech value and plug it into the IMO mapping tables to see if these different, lab values and things exist in the IMO mapping tables. If they do, now we have a new value from the IMO table to use. That next produces the HL7 message, or we produce the HL7 message. Next, we can use, in this case, IATRIC or somebody's mapping tables to further enhance that and take that value to ultimately get what 251 requires. And the last node would be the final output. So when it actually goes out to the vendor is going to receive that HL7 compliant, 251 compliant output. They might never know that that started as a Meditech drug mnemonic, went through the IMO mapping, went through somebody else's mapping table to produce the, the final drug codified value. They just get the codified value typically. The same process, but in reverse, is done for inbounds. So typically with inbounds, what happens is the data is received matching 251 requirements. So typically with inbounds, you're going to get the codified values right in the message. And then again, mapping can be used to kind of reverse engineer those and map those back to what's relevant in the hospital system, in the Meditech side, for example. And now the data is a match for what's in Meditech, which if you're going to put data in Meditech or make decisions against it, you need to know the Meditech terms and mnemonics for everything as well. So it's the same process, but in reverse. The message comes in, so going left to right here, the message typically comes in, and it's HL7 251 compliant with all your codified values. So looking at the message right there, you might not see any Meditech terminology or anything Meditech, centric. Then those third-party mapping tables are applied to potentially get that, HIS or Meditech value. And then if it's a Meditech hospital, those IMO tables can also be used next, ultimately getting the Meditech value that we're going to use. So similar process, it just depends. Are you starting in the hospital system and trying to arrive at the 251 codified value, or are you starting with the 251 codified value and trying to arrive at what the hospital wants? So sort of out in the field, what are we seeing? So far we're seeing mixed adoption with 251. Some vendors are ready for 251. Some have been doing 251 for years. I mean, we've been producing 251 even before meaningful use because some states needed that for grants. So some folks have been doing 251 for quite a while. Others are still working on it, and they're quite a ways away. Other vendors, though, might even be skipping 251 entirely. I've seen some vendors, they don't do HL7 version 251, and they're not planning on it. they're going to do things like web services and API type work, which is related to FHIR, which I'm going to show you here in a little bit, and they're not even going to touch 251 and do anything with 251. So I just like to put that out there so that you can see that vendors are kind of the whole spectrum, using 251 kind of in progress and no plans to use 251. As far as the hospital and the hospital staff and time, what does it mean for the hospital? What do these codified values mean for the hospital? Well, these are some of the more common Meditech dictionaries that we see impacted by these codification requirements. Customer-defined queries can really be used, nothing new there, but they can be used as sort of a general catch-all, to capture data values which might not always have a predictable location with Meditech. So we find that many hospitals, if Meditech standard dictionaries don't have a good match, one-to-one match with a certain field, customer-defined queries are used to allow people to type that data into Meditech. So one consideration, hospitals are going to have to maintain those potentially. The lab side, the tests, the specimen type, the site, microorganisms, the micro procedures, and the source. Other Meditech dictionaries, nomenclature, antibiotics. The provider dictionary is used because there's codified values at the provider level as well. And there are some other MIS and NMI dictionaries which are used as far as being the source of truth, for the hospital to type in these codified values. As far as the mapping goes, just some additional thoughts and considerations there. Mapping can be time intensive. It can involve thousands of entries sometimes, and it can take quite a bit of time to complete. So that's time for the hospital's team to review and approve the items. And typically, as far as planning and timeline consideration, typically the mapping needs to be filled out or almost complete before the real testing can start. So it's just another consideration in the project planning and the project timeline that all the time needed to do this mapping needs to be factored into the project timeline. As far as the mapping itself, what value goes against which lab test and things like that, that does require a fair amount of clinical knowledge and expertise, to map the proper value to the proper value, potentially thousands of times. So you'll find that you need staff that have sort of a deep clinical knowledge as well. The IMO mapping tables are typically used to aid and assist here, but even then, even if you're not filling those in item by item, you still need somebody with a clinical background and clinical knowledge to approve those maps and to actually review those and approve them and confirm that they're happy with what's in those maps. Means that typically, I call it seasoned staff. Hospital needs to be prepared to set seasoned staff aside for potentially, a fair amount of time to do that data entry, sign off, review, sign off on all the codified values and the maps, the IMO tables, and make sure that's all correct. Which, again, it's kind of downplaying it here, but it is no small effort. There's a timeline hit. You need to be prepared to coordinate those activities months in advance of any testing or attestation dates. We've had customers who didn't have their mapping tables filled out, a week before they were going to attest for meaningful use, and they had to scramble. They had to pull in extra resources and pay some people to do data entry on the weekends, for a whole weekend, the weekends leading up, and it's just, the work needed to get done. So I do like to put that out there that, generally speaking, hospital needs to be prepared to coordinate that mapping and those activities potentially months in advance, of any testing begin date. Again, some of what I talked about already, but change requests, and this does impact the hospital. So software vendors may be unable to change something once the certified feed has been certified, and vendors need to scrutinize and review every single change request. That means from the hospital side, as changes are being requested, you need to allow time for that as well. It might not be a quick phone call to just call up on a Monday and have a field change by Monday night or by Tuesday morning. It might take the vendor a couple days to review and prepare their findings and report back. So just more time that adds up in the overall timeline planning and coordination. And I just find that, as a general rule of thumb, when you're dealing with 251, even just a straightforward outbound, I mean, allowing at least a few months testing, 8 weeks testing or more for a 251 interface due to all the mapping and the potentially thousands of fields and, needing that clinical knowledge and making sure all the mapping works, it's probably a good rule of thumb. Anytime you're testing an outbound, if you allow 8 weeks or more for that, if you're dealing with 251, that's probably a good place to start. Good rule of thumb. Which is a little different because in version 2.3, I mean, we've seen hospitals go live with a brand new ADT feed that day. They test it for the morning and it works, and they go live the next day. So not every interface requires, multiple months worth of testing, but 251 definitely adds that layer of complexity when it comes down to the codified values. Briefly, I mentioned clinical documents. So clinical documents, CCDs, C32s, things like that, they're not typically transmitted as HL7 version 251. They're typically done as XML, extensible markup language, and they have a style sheet applied to make each document a little more human readable, a little easier to follow. But if you look at the clinical documents, they do contain the same or many of the same codified data values that we talked about here so far today. So not just applying to interfaces, but you also see those on clinical documents as well. So I did want to shift gears now and take a quick look at FHIR and then sort of open the line for any general questions that the team might have here today in a few moments. But so FHIR, wanted to mention FHIR because, just to make sure everyone's aware of it, but it is also part of the current stage 3 documentation, so I wanted to make sure folks were coming up to speed with FHIR and had some exposure to that. So FHIR is Fast Healthcare Interoperability Resource. That's what that stands for, resources. It's the next generation standards framework containing significant improvements over previous versions, previous standards. And FHIR does take advantage of lessons learned with previous versions, so version 2, version 251, version 3, clinical document architecture, all of that was sort of reviewed and scrutinized to get the best of all of those standards and offerings, as well as the latest web standards, things like RESTful web services, APIs, SOAP, things like that. So that's all part of FHIR, takes advantage of all of that. FHIR can be used as a standalone data exchange, can also be used in partnership with prior HL7 standards. So you could use, for example, FHIR resources and HL7 version 2.3. I know there is overlap there. Some of the key design features with FHIR, and I'll show you some of these resources here in a moment, but FHIR was designed to allow fast and easy implementations. Solutions are created from what are called resources. They're modular components called resources. All exchangeable content, really, that you could think of is defined as a resource. And the specification, the FHIR specification, does contain general documentation describing how resources are defined, a list of available resources, and implementation requirements. So just looking at the FHIR specification really gets you started knowing what the allowable resources are and how those are intended to be used. So looking at, healthcare integration, FHIR, at least the architects believe that, the majority of common use cases can already be satisfied with the current resources, either by themselves or by combining resources together. I'll show you a couple examples of that here quickly. FHIR contains what are called resource relationships to satisfy the majority of common implementation. And part of the interesting part is extensions can be used. So expandability, FHIR allows extensions to be used to allow implementers to basically build on current resources to cover the remaining content as, maybe specific workflow comes up. So the idea with FHIR is you can use all the resources that come with FHIR out of the box, if you will, and if you can find a particular relationship that those resources don't cover, and the mechanics of using those resources don't cover, you can create extensions within resources as long as you follow the right rules. You can create extensions to expand upon those resources to cover what you need to cover. So some of the key advantages, a strong focus on implementation and ease of use, concise and easy to understand spec. Spec is free. no restrictions up for use, and the term would be interoperability out of the box. You know, large set of base resources provided to solve the most common healthcare integration challenges, and again, I mentioned that expandability to cover scenarios that they might not have thought of. It does have a strong foundation on web standards, and it's suitable for a wide range of things, including mobile apps, cloud-based communications and computing, EHR data sharing, server-to-server communications in large healthcare settings, things like that. I do want to make sure we have enough time for questions here as well, so I'll just cover these FHIR resources a bit more, and then we'll kind of open the line for questions. But looking at FHIR resources, resources share common characteristics, a common way to define and represent each resource. Resources are built from data types that define common reusable patterns. Common set of metadata, which deals with the version, so what version of each resource are you dealing with. Sort of self-documenting, the human readable component. Each resource needs to contain that. Each resource has a URL, which can be addressed by. In the specification, lists all of the available resource types which are allowed. I'll show you those here in a moment. Resources are represented in either XML or JSON, JavaScript object notification. It's up to the end user, so the implementer can decide which version to use. When you look at a resource, resources can contain pointers or links to elements within other resources. So you can combine resources together, and I'll show you how to do that. Build a rich collection of healthcare information to solve complex problems. So let's take a quick look here at some of these examples. So here is the current list of all of the FHIR resources available. Quite a few there. So let's take a quick look at two examples just to see how you can tie these together and actually solve some healthcare problems. Before we do that, a RESTful API. So a RESTful API defines a set of operations which may be performed on resources, and organizations can choose which to support. So resources can be read-only, read and write, update, delete. You can create new resources, search within resources, etc. So each organization can decide if you're going to make it tighter or make it, view-only, read-only, or if you're going to allow outside entities to actually update, create, and delete and modify, resources on your system. It's up to each organization. So here's just a quick visual. This is the patient resource. I know it's probably a little bit tight to read there and small, but just wanted to show you visually that these resources are really, programming type of objects that you would deal with at the programming level, but this is just an example of the patient resource. And here's the immunization resource. So basically, anything dealing with an immunization is contained within the immunization resource, the date, the vaccine type, reported, who performed it, the manufacturer, the location, the lot number, the site, the route, things like that. So a couple quick examples before we kind of open the line here for questions. So let's take a look at, the first use case, accessing a patient record via, a mobile app, maybe a smartphone, or a patient portal. So this would be, a patient's record is on the hospital's network, and an outside application, a portal on the cloud somewhere, or a smartphone wants to actually access that patient's record, maybe pull the patient's chart onto the smartphone, for example. So the hospital would provide or expose a RESTful API, specifically for this purpose. So this is where the designers would decide, is this going to be a read-only type of API, or are you going to actually allow clinical documents to actually be pushed back in and altered? It's up to your organization. For sort of the view-only, the base case, that API would support searching and reading. So the operations would be the search and read operation, and the resources involved would be the patient. So everything about the patient, the demographic and the who, who are we dealing with? Who's the patient? Whose chart we need to return? That's that patient resource. The document reference resource, that provides access to an individual patient's documents. And then the clinical resources resource provides the patient's clinical history and clinical data. So the way that would work with that API would be the portal or the smartphone would basically interact with that API to perform the patient validation, using the patient resource, present the user with the patient's information as a result of that document search and return. So just using those three resources, an API could be written to basically just pass the patient's information in, and we'll spit back all of the patient's clinical documents, or pass the patient's information in and a certain date. We'll return all the clinical information about that specific date. Things like that. You can write APIs to do things like that, just using those resources. And the other quick use case here is using a document repository. So searching for documents across maybe a large network, cross-document sharing. So you have a document reference resource which describes a document stored within the network. So this is a specific document. You have a resource called the binary resource, which is used to store the actual documents on a server, so the actual documents themselves. The patient practitioner organization resources, those provide proper patient and provider indexing information. Whose document is this? Who are the providers on this document? Where did this document come from, etc. And then the security event resource, that's in place to actually track the use of these documents so that you have a proper audit trail to see who's accessing it and things like that. So those can be created, just those resources can be put together to create a clinical document query retrieval mechanism. So a hospital can expose an API, and if you know how to use these resources, again, same idea, pass us, the patient's medical record number and the date range, whatever you can come up with. We'll return you all the clinical documents for that patient and date range. Give us a specific provider. We'll narrow down the search and provide you just the documents that have that provider. Things like that. That's the idea there with how one would create an API. So just wanted to show you FHIR. There's a lot to FHIR, and if you have an opportunity, check out HL7.org. They have a whole page just on FHIR, a whole section just on FHIR. So there's a lot to FHIR, but I mainly just wanted to expose people today to it just to start getting that comfort level up, as it is part of stage 3. And I think, Amanda, at that point, I'd like to leave about 10 minutes here for questions if people do have questions. So I'd like to open up the lines.
Okay, all right. We do have 2 questions, and the first of which I will go ahead and answer. It was, will this presentation be recorded? And yes, it is being recorded. We will send out both the recording and the slides to all attendees at the conclusion of the webinar. For 252 for stage 3.
Well, for stage 3 with 251, let me go back and pull that up here. It is part of stage 3. So for stage 3, you'll see 251, oops, I apologize, here, at least here. So for stage 3, 251 is required for the public health interfaces, including that bidirectional immunization query, the codified components of clinical documents, CPOE, so receiving lab orders and filing and placing those lab orders uses 251, and then the lab test compendium, the list of orderable lab tests that has overlap both with bringing lab orders in for CPOE and with sending lab results out. So that's the main 251 overlap that we're seeing so far. For 252, that's a good question. Haven't looked a ton yet at 2.5.2 for stage 3, but that's something, I guess, Amanda, if we know who asked that question, something we could take a look at and provide some info after the call on that potentially.
Okay, all right, I have their name, so we'll do that. And at this time, we have no more questions. If you do have one, please remember you can enter it in the questions pane on your control panel, and I'll be glad to ask. Okay, here comes one now. How is all the mapping typically being done? Are the hospitals doing it internally, or are they bringing in outside resources? I imagine some of both, but what type of percentage breakdown are you seeing?
I would say that I know with the IMO, that is handled to get the hospital started. So with the IMO mapping, I know that that involves users going in and doing quite a lot of the work, quite a lot of the mapping. So at least on the Meditech side, a lot of what we're seeing is, for us, it starts there. You know, the hospital's already filled out their IMO tables, or I'm sorry, IMO's already filled out the tables and the hospital's approved them, or IMO is working on the tables, or IMO hasn't filled out and the hospital is working on, you know, approving them. As far as that, that's more approval, you know, making sure that that would be a clinical, you know, supervisor, clinical type supervisor group going through and making sure that what is in the IMO tables the hospital's comfortable with before, you know, approving those. After that, you know, building these mapping tables, we do see that specifically for home meds and allergies, it can take a fair amount of time, you know, hours-wise, to go in, just because there's so many different, you know, how many different allergies are there, how many different home meds are there? There's quite a few. So we are seeing that many hospitals do have to spend a lot of time in-house. In terms of, you know, are their staff doing it, or do they go out and have, you know, data entry folks come in and help? We've seen that as well. I don't know that that's as common, because the problem is that clinical knowledge. It's hard to have somebody who doesn't have the clinical knowledge map this value over here to the correct acetaminophen, you know, drug, or morphine drug, or, you know, pick your drug, right? So that's usually where I think most hospitals do it in-house. They probably have data entry people help, but it still comes down to the right clinical people filling that all out, which would be in-house.
Okay, Rich, that is all the questions we have right now.
Okay. Well, I wanted to thank everyone for their time today, and I think, Amanda, if anyone has another question?
Yes.
Okay.
Are there other sources besides IMO?
For the mapping? Yes, the IMO is done typically on the Meditech side. I know that that's their vendor of choice, you know, for that part. There are third-party companies out there that do similar, and what they'll do is go in and actually similar. They'll go in and they have staff to fill out these mapping tables, and they're structured similar way where the hospital will receive the map as the finished product and then approve it. You know, go through it and make sure it's correct and accurate. I'd say, Amanda, we don't do that per se, but we do have, I think, some vendor partnerships with folks who do that if anyone's looking for a potential reference there.